Okay, today we are discussing about resultant force. Now, what is meant by resultant force? If the number of force, let us say P, Q, R, are acting simultaneously on a particle, then it is possible to find out a single force which could replace them, that is, which could produce the same effect. The same effect is important term. Same effect as produced by all the given forces. It means that let us consider this force system. Let us say this P1, P, Q, R. These are the forces, three forces which is acting over this particular body. And due to these three forces, whatever may be the effect which is produced due to these three forces, the same effect will be produced by this single force R. These three forces, whatever may be the effect produced by the three forces, the same effect will be produced by this resultant force R. And R is the only one force. R is the only one force. The single force is called the resultant force, and the given force R is called the component force. Okay, it is very simple statement or very simple meaning of this resultant force. It means that if there are the number of forces which is acting over this body, and whatever may be the effect produced by that number of forces, the same effect will be produced by this single force. The same effect will be produced by this single force, and that single force is nothing but what? Your resultant. And how to find out this resultant? There are the number of ways to find out the resultants. Now let us see one by one. Very first is the composition of force. The process of finding out the resultant force of a number of given force is called composition of force or compounding of force. This finding the resultant of a force is also called it as composition of force. It also called it as composition of force. It is the again process to find out the resultant force from the number of forces from the number of forces given is called composition of force. Now the method for the resultant force. What are the different types of method which is applicable to find out these resultant forces? There are many methods for finding out the resultant force of a number of given forces, yet the following are the important form of subject point of view is given. One is the analytical method and another one is the method of resolution. Now, analytical method for the resultant forces. The resultant forces of a given system of force may be found out analytically by the following method. Now, very first method is the parallelogram law of force, and second method is the method of resolution. As we have seen earlierly, parallelogram law of force, as we know that if there are the two forces acting simultaneously on a given body at a point are replaced in magnitude and direction by the two adjacent sides of an parallelogram, their resultant is represented in magnitude and direction by the diagonal of parallelogram, which passes through the point of intersection of two side representing the forces. Now here figure shows that there are the two forces F1, F2 are the sides of an parallelogram, and R is the diagonal of that parallelogram. And how to find out this R? By using this formula. R is the resultant force. The effect of these two force will be produced. The same effect will be produced by this resultant force R. And how to find out this resultant force R? By analytical formula which is derived from the parallelogram law of force. And R is nothing but what? R is the resultant force. R is equal to square root of F1 square plus F2 square plus twice F1 F2 cos theta. And here this resultant R making an angle alpha with F1, and to find out alpha, tan alpha is equal to F2 sin theta divided by F1 plus F2 cos theta. These two formulas are important when there are the only two forces which is acting over the body. In this condition only, this parallelogram will be applicable. If there are the more than two forces, this parallelogram will not be applicable. And forces should also be concurrent type of force, means it should be passed through a single point. It should be passed from the single point. Coplanar concurrent force system should be there. Then and then only this formula will be applicable. Now let us again return to the resultant. Okay. And another method is the method of resolution. Now the resolution of force means what? It is the very important parameter or point under this engineering mechanics is concerned, and it is very important terminology how to resolve the force, resolution of force. Now let us see what is meant by the resolution of force. The process of splitting up the given force. Splitting up, what we have to do? We have to splitting up the given force into number of forces, number of force component, without changing its effect on the body, without changing the effect of the body, is called resolution of a force. A force is generally resolved along two mutually perpendicular directions. Two mutually perpendicular direction. In fact, the resolution of force is the reverse action of the addition of component vectors. It is the reverse process of composition. Resolution means splitting up the number of forces. If the single force is there and we are splitting into two components, it means that it is the inverse process of composition of force. Okay. Now let us see here by a simple example how to resolve the force. Okay. Now let us see this F force is having the intensity or magnitude of 20 kilonewton, which makes an angle with horizontal 30 degree, and we have to resolve this force, which will be giving the same effect as that given by this single force. Now this one is the only single force, and we have to make this. There are the two equal component, not a equal component. There are the two component which will be producing the same effect. Okay, let us see how to resolve this force. Now let us say this force, if I resolve, there will be the two component. What here the statement is given, two mutually perpendicular component, mutually perpendicular. Now fx and fy, these are the two mutually perpendicular to each other. Perpendicular means here the 90-degree angle will be there in between these two forces. Now if the force of this direction of this force is in this direction, it means that your fx and fy, if I resolve these two forces in this direction, what will be getting? The direction will be in this direction and in this direction. Okay. Now, how to find out the magnitude of these two forces? How to find the magnitude of these two forces? Now let us see. As we have seen, these are the fx and fy. These are the two force components. Now let us see. I move this force. I have moved this force from this to this. Okay, it makes one triangle. Now if you see here this triangle, this angle is of 30. Fx is the one of the side of triangle. Fy is the another side of an triangle, and F force is the third side of your triangle. Now if you see in this figure, cos theta is nothing but what? It is the adjacent side upon hypotenuse. Adjacent side is how much? Fx, and hypotenuse is what? Your f. Therefore fx upon f is nothing but what? Your cos theta. From this I can calculate fx, and fx is nothing but what? F cos theta. From this formulae I have derived fx is equal to f cos theta. Now similarly, sin theta is nothing but what? opposite side upon hypotenuse. And now here opposite side of this theta is Fy, Fy upon F. F is the diagonal or hypotenuse. Means sin theta is equal to opposite side Fy divided by hypotenuse is F. Now from this Fy is equal to F sin theta. It means that this resolved force is nothing but what? F cos theta and F sin theta. And theta is nothing but what? The angle made by this force with the horizontal. Okay. Now let us calculate this term. Fx is equal to F cos theta. F is how much? This F is 20. And theta is how much? Theta is 30. Now let us solve this. 20 is the F, cos is 30, cos 30. Now solve this. 17.32 is the magnitude of this force Fx. Similarly, this Fy force is nothing but what? F sin theta, and here F is of 30 and angle is of, sorry, F is of 20 and angle is of 30, means 20 sin 30 is Fy. Now let us calculate this term also. Now let us solve this term. Twenty sin 30, 10. This, it means that Fy is 10 kilonewton. Fy is 10 kilonewton. It means that this Fx is 17.32 kilonewton and Fy is of 10 kilonewton. If we apply over the body instead of this force F, 20 kilonewton force F, making an angle 30 degree with horizontal. If I apply this force instead of that force, if I apply these two forces which are mutually perpendicular to each other, having the intensity along the x direction 17.32 kilonewton and 10 kilonewton along the y direction. If I apply these two forces, it means that I have split up. I have split this force, split up the forces into number of component. I have made these two component without changing the effect on the body. It's called resolution of force. And these two forces are two mutually perpendicular in direction. Okay, and such two forces mutually perpendicular direction is producing the same effect as that produced by this single force. This process is called resolution of force. This is process of resolution. This force is resolved into two components which are mutually perpendicular to each other and which is giving the same effect which is produced by this single force. The same effect is produced by these two forces, and this process is called resolution of force. Now what will happen if the angle, instead of this angle making with the horizontal, if I say that this angle made with the horizontal, instead of this it makes an angle with vertical. What will happen when the angle made by this force is given with the vertical axis? Now let us see this process also. Now let us see. It makes an angle 30 with the vertical axis. Now what will happen? Same, this one is Fx, this one is Fy, only the angle is with the vertical axis. Now here what will happen? This Fy and Fx, these are the two sides of a triangle. Let us say these are the two sides of a triangle. Now again, now this one is Fx is the one side, Fy is the another side, and F is the third side of a triangle, and angle theta over here. Now again from the geometry, cos theta. Now again cos theta is equal to what? Adjacent side upon hypotenuse. Adjacent side is how much? Fy. Fy upon F. Now again here Fy is nothing but what? F cos theta. What will happen here? Due to the angle theta with the vertical axis, the cos component arises to the vertical. Previously, this cos component was to Fx. Okay, right now it is for Fy. Now similarly, sin theta is equal to what? Opposite side upon hypotenuse. Opposite side is Fx upon F. Now from this, Fx is equal to F sin theta. Again, let us put the values. What will happen? As what previously we have calculated the same value. Now here Fy is 20 cos 30. It becomes a 17.32 kilonewton, and Fx is equal to F sin theta. Therefore, 20 sin 30 is equal to 10. Previously this 10 was over here and this 17 was over here. Now the same effect is produced by this force. Only this force single force is split up into these two forces, which will be giving the same effect as that given by this single force, and this process is called as resolution of force. This process is called as resolution of force. Okay, now from this, the principle of resolution, it states that the algebraic sum of resolved component of number of forces in a given direction is equal to resolved part of their resultant in the same direction. Finding the component of forces is called resolution of force and is exactly opposite process of composition of force. It is exactly opposite procedure of composition of force.